Welcome back. Today we continue our series, our course in system design, system design fundamentals. Today we will talk about the stateless web tier, and long story short, a stateless web tier is refers to a design pattern in web application architecture where the web servers that handles incoming client requests and serve web pages do not maintain any session state or user specific data between requests. In a stateless architecture, each client request is treated independently, and the web server does not rely on information from previous requests to process the current one. What that means. So let's just try to first make an example of a stateful architecture. So let's say that we have here a client. A client, and this client is connected with a web server. And the web server holds some information about this specific client, like session data, and maybe like profile image. Okay, and let's call this client 1, and let's call this web server 1, and I guess everything looks quite good, everything looks quite fine. However, let's try to duplicate this relationship, and let's call it this 2 and 1. Let's give it a different color so it will be easier for us to okay, and let's say that we will have another one will be okay, let's call this client 2 and this client 3 and this web server 3, and let's change the color and make it red. No. Okay, and let's try to see it right now. So as you can see, the stateful architecture, it's the stateful architecture, a stateful web tier is a design pattern in web application architecture where web servers that handles the client requests maintain and manage the session data or use specific data between requests. In contrast to stateless web tier, which treat each client request as independent. The stateful web tier retain information about the client interactions with the application across multiple requests, and this how it looks like, and it works fine. However, the problems rely on right now we are trying to scale our web server. So we have 3 web servers and we have 3 clients, and each client connected with this web server. Let's say this web server was offline, so the client will have to connect with this web server for the second one. However, all the session data and all the session data of the client 1 of this client is gone right now, and all this data doesn't belong to this client anymore. So right now we lost the data, and maybe in the scalable applications the servers may go off often, so we'll have all the time lose, and maybe we could lose the data most of the time. So how should we solve that? So we can solve that by using the stateless architecture. So let's say that we will take all the session data from the web servers, okay, and no session data, and the servers will not have the session data, so it will be stateless. So basically, if you can see right now, each request, it will be independent. Client 1 could reach to web server 2, web server 3, because it doesn't matter. And we will can create like a storage here. Like you can think that we could create a storage, like shared storage. And the web servers will connect with this shared storage. And by this way, if, for example, web server 1 gets offline and the client 1 try to connect with web server 2 instead, the client 1 will be able to get its own information from the shared storage, because we are not saving the data and the session data in the servers anymore. And in this one, it's better to implement. It's better right now, like what we are providing for. It's the ease of horizontal scaling. This is better for horizontal scaling. It's easier for fault tolerance. Like we improve the fault tolerance. Like the stateless systems are inherently more fault tolerance. If one server fails, the maybe the load balancer, because the load balancer, it will it will be the component that responsible for redirect the client requests to different servers. So the load balancer will try to send it to different web servers, and we are right now we improved the fault tolerance. We simplified maintenance, like simplicity. The stateless web tiers are simpler to design, implement, and maintain. There is no need to manage session data and deal with session expiration or synchronization data across servers. The better thing also that we improving the caching and performance, like the effective caching, like the stateless design can make more effective use of caching mechanism, because response are generally cacheable without concern about serving stale or user specific data to different users. Also, we have the stateless APIs. It's a competitive with the RESTful APIs. We have with the cost efficiency also is better, because the resource efficiency, because the stateless systems are often more resource efficient, because they do not need to allocate memory or storage for session data. And yeah, so it's better on so many levels. So let's try to put let's go to our system, this system that we're trying to build. And let's try to put our own shared storage. So we will put it. We have the let's here, and let's copy this one. Great. And I will call it. Let's make it NoSQL database, because I guess there is no relations and we don't know how that will look like. So yeah. Let's put this blue. No. And let's make it like that, and the color should be this. Okay, so in this one, we move the session data out of the web tier and store them in the persistent data store. The shared storage could be a relational database or memcache, Redis, or NoSQL, etc. The NoSQL here data store is chosen is it is easy to scale. The auto scaling means adding or removing web servers automatically based on the traffic load after the state is removed out of the web servers. The auto-scaling of the web tier is easily achieved by adding or removing servers based on the traffic load. And that's it for today's video. Before I leave, I maybe tell you what the system is all about right now, and let's just try to talk about each component. First, the user tried to get the IP address of the load balancer from our domain name system. This is how it works. The user tried to send the domain name, like maybe facebook.com, youtube.com, anything.com. This is called the domain name. Once the DNS get the domain name, it will send back the IP address of the load balancer. Once the user is get the IP address of the load balancer, it will try to connect with the load balancer, and the load balancer will try to distribute all the incoming requests across multiple web servers. The web servers, if they have a GET request, they try to get it from the cache. If they can find it in the cache, they will get to any DB slave that support a read operation. Since when they get it, they store it in the cache, and after that, they will send it back to the user. If the user have its own information like user session ID or token or something, it will be stored on in NoSQL database. It's a shared storage to all web servers. We have the CDN to serve our assets like images, JavaScript, HTML files, to make sure that we improve latency and we improve we reduce the latency and improve the performance. We have the master database here that is responsible for the write operation, like delete, add any new thing to the database, and since anything and when anything is being added to the database master, the data being replicated to across the two slaves. So that's it for today's video, and that's it for about the stateless web tier. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video, and see you in future problems.